everyone, this is Learn Psychology with me, your mentor, Naz. Hello, welcome to our final lesson of Learn Psychology. This week we will have some fun fact quizzes. We will learn about writing a scientific report for experiments we perform and why they're important for researchers. We will learn about the Stroop effect and learn how to perform the Stroop task. You can then ask your friends and family to do this challenging experiment with you. And, as usual, we will end the lesson with some extra practices for you to try out in your own time. Now it's time for our first fun fact quiz, this week about dogs. What colors do dogs see in? A. Red and green, B. Black and white, and C. Yellow and blue. Think about your answer. If you need more time, pause here and come back when you're ready. And the correct answer is C. Blue and yellow. Have you heard the myth that dogs are colorblind and they can only see in black and white? Well, that is wrong. We as humans are trichromatic, which means we have 3 different types of cells in our eyes which let us see variations of red, blue, and green colors. Dogs are what we call dichromatic and have only 2 different types of cells in their eyes which let them see variations of only blue and yellow colors. In the same way as dogs, some people who are colorblind can only see certain colors but not others. It is very uncommon for humans to only see in black and white. Now let's jump into our lesson. Let's talk about scientific reports. As we learned in our last lesson, researchers follow the scientific method to perform experiments to find answers to their questions. Remember our experiment about the effect of sunlight on fruit production of plants? We followed the scientific method. We asked the question, did our research, we formed a hypothesis, we performed an experiment to test our hypothesis, and reached the conclusion that plants that receive more sunlight produce more fruits. So, what's next? We need to write our results and share them with others. So, what should we include in our report? All well-written scientific reports are composed of 3 sections. First is our introduction. Here, we talk about what our question was and what our research told us about this question. Second section is the methods section. Here, we talk about what equipment we used and how we used them. And the final section is the conclusion section, and here we talk about what we found and why this is important. For example, in our plant experiment, we found that plants that receive more sunlight produce more fruits. Why might this be important? With this result, we can inform the way farmers take care of their plants to produce more fruits and that they can sell and make more money. But why are these reports important? We found the answer to our own question. Why should we write about it since we already know? Our scientific report provides instructions for other researchers to repeat the experiment or build on it to confirm that our results didn't just happen by chance and that they're reliable. Scientific reports are analyzed by our fellow researchers. They evaluate the methods we used and identify any potential flaws in our logic or methodology that might make our results untrustworthy. Finally, our report clearly explains to other researchers why our results are important. Let's practice now. In this exercise, I want you to find what information goes into each section of the scientific report. We have the introduction, methods, and conclusion section. Now, take some time to decide which information goes into which section. I will give you some time for this. If you need any more time, pause here and come back when you're ready to see the answers. Now let's look at the correct answers. In the introduction section, we have our question and our research. In the methods section, we list our equipment and details about how we use them. And finally, in the conclusion section, we write down our results and explain why they're important. Very good. Let's do a famous psychology experiment, the Stroop task. Meet 𝙭𝙧𝙖𝙧. She is a psychology researcher and she needs our help completing her latest research project. She told us that she wants to investigate a psychological phenomenon called the Stroop effect. Now, let's help 𝙭𝙧𝙧 using the scientific method. First, we start by asking a question. And our question is, how does the Stroop effect work? Now, we need to research our question. The Stroop effect was discovered by a researcher called J. Ridley Stroop in the 1930s. Stroop effect slows down your ability to name the colors of the ink when the written word is a different color. For example, it is more difficult to name the color of the ink this word is written in, which is green, when the written word is red. But it is easier to name the color of the ink of this written word, which is blue, when the written word is also blue. Don't worry if this is a bit confusing now, you will get to practice this in a second. Next, we form a hypothesis. From our research, we can expect that people will read color words faster than they can name the ink the color word is written in. And now comes the exciting part. We will do an experiment to test our hypothesis. We want to compare people's speed when they're reading color words and when they're naming the ink of the color words. Let's jump into our experiment. Here are the instructions for our experiment. When the video moves on to the next slide where you can see color words, pause the video. First, read the words, ignoring the color the word is written in. Time yourself doing this and write down your time. Then, ignore the words and say out loud the color the word is written in. If you make a mistake, stop, correct your mistake before you move on to the next word. Again, time yourself doing this and write down your time. If you can, get other people to do this as well and write down their times underneath yours. And you need a timer for this task, so either use your phone's timer or Google Timer. Pause the video here to perform the experiment and come back when you're ready to discuss your timings. As an example for you, here is me doing the experiment. First, I will only read the words. Blue, green, yellow, red, blue, red, yellow, red, green, blue, green, yellow, red, blue, blue, yellow. That took me 11 seconds. And next, I will name the ink color of the words and time myself doing that. Red, yellow, blue, green, yellow, green, red, blue, yellow, green, blue, red, yellow, and green. That took me 21 seconds. Great! Now that we completed our experiment, we move on to the final step of the scientific method, drawing conclusions. Which task were you faster at? Was it reading the words or naming the ink color? I was faster at reading the words by 10 seconds. Which task was more difficult and why? I found naming the color more difficult. And finally, what do you think caused this difference? What is happening in our brain when we're trying to do these two tasks? I'll give you two options. 1. When we want to name the color of the ink, we find it difficult to ignore the written word. 2. Reading is easy, but the colors in the test were not easy to name. I'll give you some time to think about it. As usual, if you need more time to think, pause the video here and come back when you're ready to see the answer. And the correct answer is, when we want to name the color of the ink, we find it difficult to ignore the written word. Well done! Now let's explore that answer a bit further. Let's take this word as an example. Blue written in red ink. We were faster at the task of reading the word. When we see a word, our brain's automatic response is to read the word. We can easily ignore other aspects of the word and read it. So our immediate response to this word is blue, and we say it out loud and move on to the next word. But when the task becomes naming the ink color, we still see a word. Our immediate reaction is to read it, so blue pops to mind. Our task is to name the ink color. So we first ignore the word, then pay attention to the color and say red. That's twice the work, so we become slower at this task. There are many variations of the Stroop task you can use, and it is very easy to create these on your computer. All you need is words and colors. Here are some examples for you to try out. Switch the color words with nonsense words like 𝙤𝙤𝙧𝙤 𝙤𝙤𝙧𝙤. It can be any nonsense word that you want. Or switch the color words with other words that brings colors to mind. For example, tree, which brings to mind green, or sun, which brings to mind orange or yellow, or sky, which brings to mind blue. Let's end our lesson with a fun fact quiz about Stroop troopers. Who do you think might be immune to the Stroop effect? A. Young children who don't know how to read. B. Colorblind people. C. The elderly. I'll give you some time to think about your answer. If you need any more time, pause the video here and come back when you're ready to see the answer. And the correct answer is A. Young children who don't know how to read. Remember, since the Stroop effect happens because our automatic reaction is to read the word, which delays us from paying attention to the color, if you don't know how to read, this cannot happen. So, young children are Stroop troopers. You might have thought B is the correct answer. This was a trick option. We can't really say colorblind people are immune to the Stroop effect for two reasons. 1. Colorblind people would not be able to complete the Stroop test since they would not be able to correctly name the ink colors. And second, as I mentioned in the first fun fact quiz, colorblind people can still see some of the colors. Therefore, their color naming for the ink colors they can distinguish, for example yellow, will still be affected by the written word. Finally, here are some extra practices for you to try out in your own time. Follow this link to try this automated Stroop experiment, which will do the timing for you. Invite your friends and family to try it as well. Now that you know how to write a scientific report and you performed an experiment, you can use the scientific report template to write about your Stroop experiment. And if you had fun doing the Stroop test, create your own Stroop experiment following the advice on many variation slides and try it on your friends and family. Until I talk to you again, maybe next year, stay curious and don't forget to have fun. Well, my curious friends, I hope you enjoyed learning about psychology with me and had fun doing so. I hope to talk to you again next year, and best of luck with school.